first example of a shaded region problem, and we were exposed to this a little bit within the mini circle unit. They had some questions about circles, but then they're also asking about shaded region problems. Now, whenever we have a shaded region, we should do, marker, the area of the shaded is equal to the area of the whole thing minus the area, let's see if I can squeeze it in, of the unshaded region. So we have the area of the shaded equals the area of the entire thing minus the area of the unshaded. So here we have two semicircles drawn inside large circle B. The semicircles intersect at point B, which is the center of the large circle. From A to C is 8. We want to know the total area of the yellow shaded region. Now, right away, when I see this problem, I'm thinking it's a calculator problem when I'm talking about area, but most likely this is a no calculator problem, and you'll see why. And now remember, back to my circle unit, shout out Mr. Zamorsky, 8th grade math teacher. Cherry pie is delicious. Circumference equals pi times diameter. Apple pies are 2. So when we're talking about the area, we want to do pi times the radius squared. Now, if A to C is 8, that means the radius of the big circle is 4. So the area of the whole entire thing is equal to pi times the radius, which is 4 squared. Now, let me erase this. We have two semicircles within the yellow region. So essentially, it's like we have one circle of this size. Now, if the radius BC is 4, that means the radius of this little circle is 2. Therefore, we get pi times the radius, 2 squared. Now, like I said, we peek at the answers and we see that it's in terms of pi, so we don't have to, get any decimals or anything. So 4 squared is 16 pi minus 2 squared, 4 pi. And now 16 minus 4, 12 pi. So the area of the shaded region in this example is 12 pi. So this formula should be used basically every time we have a shaded region problem. Okay, on to the next one. Here, so we have another shaded region problem. We're not looking at circles this time, rather we have rectangle and some triangles here. So let's see what this problem is asking. So rectangle ADEH has an area of 84. AD, so this length of the rectangle is 12, and AB, let me use a different color, AB is equal to BC, equal to CD, equal to GF. So that's going to be important here because these triangles are related, and you'll see why in a second. But basically, they're going to be equivalent triangles based on the fact that they have the same height, the same base, and they intersect in the middle. So here, the first thing we should figure out, and I guess it's helpful if we have our formula. So the area, I'll write it again, area shaded equals area of the whole thing minus area of the unshaded. Sorry, that's so messy. I had trouble squeezing it in. But let's go back to this 84. So the area for a rectangle is just base times height. Now, it tells us that the area is 84, and it tells us the base, AD, is 12. So we want to figure out the height of this rectangle. So 84 will divide both sides by 12, and we should get the height of this rectangle is 7. So each side here is 7. So again, we're looking for the area of the shaded region, but we already know the area of the whole thing, which is this 84. Now, we want to figure out the area of one of these triangles. Now, if the area of a triangle is 1/2 base times height, for this particular triangle, since we know that this, basically there are 3 segments alongside AD, which is 12, which would make each little segment AB, BC, CD, and GF, that would be equal to 4. So each one of these is equal to 4. So we have 1/2 times the base, which is 4, times the height. Now the height of the triangle is not one of these sides, but rather this. Now if it's halfway up, the whole total height of the rectangle 7, which would make the height of the triangle 3.5. So we could plug that in. And that makes the area of one triangle is equal to 7. Now, there are 2 triangles, which makes the area of the triangles 14, because we have to double that. Now, again, we go back to our formula. We have the area of the shaded equals the area of the whole, which is this 84, minus the area of the unshaded, which is 14. And 84 minus 14 is 70, making our answer choice D. On to a couple examples of mixtures. And since this SAT problem is a fill-in, we can't use a strategy of, guess and check or plugging in numbers that the answers have. So let's read this problem and then let's figure it out. So how many pounds of coffee worth $1 per pound must be mixed with 15 pounds of coffee worth $1.60 per pound to attain a blend worth $1.20 per pound? So basically what we have here is we have to take this information and put it into an equation. And I like to use what's called a grouping method. So if we have this grouping method, we're basically going to group things where each group is going to have an amount and a type. So the amount, it could be pounds, ounces, liters, tons, etc. And the type would be, most likely it's going to be the price. Could also be a percent. But anyway, so our first grouping, I'll do it in green, is going to be this coffee worth $1. So I don't know how much or how many pounds of coffee I need, so I'm going to call it X, and that's worth $1. And we're adding that to our other group, which is 15 pounds, and I'm not going to do that, but worth $1.60, and that's equal to our last group, which, if we have X pounds and 15 pounds, we have X plus 15, that's a 5, worth $1.20 per pound. Now we basically have an algebraic equation where we're going to set this up. We have 1 times X plus 15 times $1.60 equals 120 times X plus 15. We just multiply. We're taking these two numbers and we're multiplying them by each other, and we're going to add them up. So we have X plus 24 equals 1.2 x plus, just distribute, 18. Now we want to get the x on one side, so when we'll subtract 18 to the other side because I'm running out of room. So 24 minus 18, 6 equals, and then 1.2 minus x is going to be 0.2x. We're going to divide both sides by 0.2. Let me finish it up here. So 6 equals 0.2x. Divide both sides by 0.2. And 6 divided by 0.2 is 30. So this would be a fill-in question, and we need 30 pounds of coffee worth $1 per pound in order to make this mixture where the blend is worth $1.20 per pound. So this grouping method where we have an amount and a type in each group. This is group 1, 2, 3. Here is our last example of mixtures for now. So how many fluid ounces of 99% isopropyl alcohol solution needs to be added to 4 ounces of 91% isopropyl alcohol solution to yield a 97% alcohol solution? So if we go back, we're going to use the same grouping method with an amount and a type. And in this problem, again, we're going to have, we got our two mixtures and then equals our third. So here we have 99% times X ounces, and we know that we have 4 ounces of this 97, or 4 ounces of this 91% alcohol solution, and we want to end up with a 97% alcohol solution. And we know that if we have X ounces plus 4 ounces, the total number of ounces is X plus 4. So now we set this up algebraically. We get 99x plus 91 times 4 equals 97 times x plus 4. Now we're good to go. Simple algebra problem. 99x, 91 times 4, 364 equals 97x plus 97 times 4, 388. We want to get all the x's on one side, so I'm going to subtract 97x. And to the other side, I'm going to subtract 364. So 99x minus 97x, it's going to be 2x, equals 388 minus 364 is 24. Divide both sides by 2, and we should get 12 ounces, which is choice C.